Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about compile-time polymorphism in Java. You will understand what it is, how it works, why it is called compile-time polymorphism. And also we will see different examples using method overloading. So, as we already know, polymorphism. Poly means many. Morphism means forms. So polymorphism means many forms. So there will be one functionality with many forms. What do you mean by functionality? Functionality, or you can say methods. Okay. So we can have same method name but different forms. Okay, same method name but many forms, different forms. What do you understand by these forms? Forms means you can say different implementation. Okay, so method name will be same but different implementation will be there. Implementation means definition of that method, what that method will do. That is definition, method definition. So method name will be same but method definition will be different. Okay, so how it is different we will see. Okay, so first question is, what is compile time polymorphism? Why we are calling this compile time polymorphism? Okay, polymorphism we know, one method with many forms, many implementation. But what is this compile time? So this thing we already know, right? One method with multiple behaviors or multiple implementation. Okay, whatever word we can use, but the meaning we should understand what it is. Okay, so method call. What is method call? So we will be having different method. So different method means method definition. Okay, different method definition. But when this method definition will get called, okay, so this depends on the method call. So we'll be having one method call. So method call means what? Linking method call means which definition it will call. So based on the parameter, based on the method name, so based on these things, that particular method will get called. Okay, I hope you understood the method definition and method call. Method definition means what that method will do. Method call means which method to call. Now, method call resolved during compilation. So whatever this process I told you just now, method call, which method to call. So these things will happen during compile time. Okay, that's why we are calling it as compile time polymorphism. Okay, so method call resolved during compilation, or you can say method binding. In the previous video I explained what method binding is. Method binding is linking method call to method definition. Which method definition it will go? So that linking is called method binding. So method binding means what? Linking method call to method definition, which there are so many definitions, right? So which definition we should go? Which method should be called? So that linking is called method binding. And this method binding happens during compile time. That's why we call it as compile time polymorphism. Okay. And some other names are also there. Also called static polymorphism or early binding. So these are the other names of compile-time polymorphism. Okay. Static, why static? Okay, before static I will explain this. Why early binding? Why they're using this binding term? I just now explained method binding, right? So method binding means linking method call to the method definition. Which definition? Okay. Then why early? Early means during compile time only. Compile time means whenever we are writing the code, it will compile automatically. Java will compile the code automatically. And when we run the program, okay, so that becomes runtime. So runtime means late binding. So in IntelliJ we know, right? In IntelliJ, see, this is IntelliJ, right? If we are writing something, here, so see, I have written one line, it is compiled. Okay. And let's say I will int a equals to 10. Now, again I will write int a equals to 10. Or let's say 20, whatever. So these 3 lines of code I have written, it is compiled automatically. While writing only, it will get compiled. How? See the compilation error. Compilation means what? .java file will get converted into .class file. It is showing compilation error. Variable A is already defined. So when we compile the program, let's say we are compiling the program. So after compilation, it will go to runtime. So whenever I have written these 3 lines of code, when I will compile the code, it will compile. See, it is giving compilation error. Okay. I'll delete this thing. So compile time happens early and runtime happens late. So that's why we call compile time polymorphism as early binding, and runtime. Okay, we will see in the runtime, but before I'm telling runtime, what we will tell, we will call it as late binding. Okay, you can forget this for now. Focus on early binding. Compile time means early binding. Okay, let's move. So how is it achieved? What is it achieved? Means compile time polymorphism. Okay, so compile time polymorphism is achieved through method overloading. So if we are doing method overloading, that means compile time polymorphism is achieved. Okay, how? So what we will do in method overloading? What is method overloading? So we have set of rules of method overloading. What is that rules? What are those rules? Same method name, or you can say method name should be same. Okay, now number of signature can be different. Signature can be different. Now we will think, what is this signature? Signature means number of parameters in the method, or it can be type, or you can say data type, or you can say both parameter as well as data type. So this is signature. So we have 2 rules of method overloading. First rule is method name should be same. Okay, let's say we defining one method add int a comma int b. So this is one method. Okay, we are writing lines of code and same method name. What is first rule? Same method name. Okay, I have kept the method name as same. Now int a comma float b comma int c. Now see, method name is same, but signature is different. Signature means what? Signature means what? Signature means it can be number of parameters. See here only 2 parameters. Here 3 parameters. Number of parameters. It can be data type. See here. Here I'm using float. Here I'm using int. It can be data type, or it can be both. See, in this example, it is both. Number of parameter is also different, and data type is also different. So this is signature. So signature can be different. So with these two rules, we can do the method overloading. And if we are doing method overloading, we can achieve compile time polymorphism. Why we are calling it as compile time? Since during compile time only method binding will happen. Method binding means what? Linking method call. So let's say I'm calling this method as add 2, 3. Now tell me which method will be called. So here we have 2 parameters, right? In which method 2 parameters are there? This method. So this method call will call this method. So this line is what? Method call. This line is what? What is this thing? This whole thing is method definition. Okay, this is definition. And what is method binding? Linking method call to the method definition. See, this is also definition, method definition. But this, based on this call, it is linking to this method. Why? Because this is 2 parameters, and here we are providing 2 parameters. So method binding means linking method call to method definition based on the parameters, method name, those things. So method binding, you understood. So method binding is happening during compile time. That's why we are calling it as compile time polymorphism. So we are doing method overloading with following this set of rules, and this method binding is happening during compile time. That's why we are calling compile time polymorphism. So compile time polymorphism is a type of polymorphism where the compiler decides which method to execute, okay, before the program runs. So before the running of program, the compiler will get execute. And since the decision is made during compilation, it is called compile time polymorphism. And the previous slide we have seen, it is also known as static polymorphism and early binding. Why early binding? Because method binding is happening early during compile time. That's why it is known as early binding. Okay. So, and in Java, it is achieved by method overloading. So method overloading means multiple methods can have the same name. Here I have written, no? Yeah. So method overloading means multiple methods can have the same name. This is first rule. Okay, but different in parameter, different in data type, or both. So that's why we say signature can be different. So the compiler chooses the correct method based on the argument. Here we have provided 2 arguments. Here 2 parameters. So it will link this method call to this method definition. Okay. Okay, let's go to IntelliJ and see some examples to get better clarity. Okay. So okay, I will create one method here. Okay. So I am creating one method void add. Okay. Int a comma int b. Oh, int b. What I am doing, I am simply printing a plus b. So it is just adding 2 numbers. Okay. Now I am creating one more method. What is the rule of method overloading? Same method name, and signature can be different. Signature can be different. What do you mean by signature? Signature means number of parameters. number of parameters. So it can be how? Let's say int a comma int b comma int c. So now tell me, number of parameters is same or different? Signature means what? It can be number of parameters can be different, and signature can be data type can be changed. Okay, we will use one more. Data type can be changed, double a comma double b. So this is also method overloading. I will return a plus b. Now signature difference means number of it can be number of parameters that is different, it can be data type that is different, or it can be both. Both means in the same method number of parameter is different. Let's say one more, I will create one more. Okay, number of parameter is different, also data type is also different. Let's say double, I will make it double. So along with number of parameter, data type is also different. So these are the example of method overloading. Same method name, add, but signature is different. Signature means number of parameter. See, 2, 3, 2, 4. Parameters are different. Number of parameters are different. Data type, second point. Here int, here double, here double. Data types are different, or it can be both. Number of parameters as well as data type. So that's we call signature. But method name will always be same. And one more rule is there for method overloading, that is compiler ignore the return type. Compiler does not see these things. Compiler will ignore the return type in method overloading. Okay, now this is what method definition. Okay, why method definition? We are defining a method, what it will do. That's why these are method definition. Now we will call the method. I will put it static. Okay, so that I can directly call the method. So I can directly call the method. That's why I added static. Okay, so now I can pass 10, 20. So I have provided like this. Which method is getting called? This is what, first of all, this is method call. Method call. So what is method binding? Method binding is what? Method binding is what? Method binding is linking method call to method definition. Now tell me, this is method call. Now, based on the arguments, how many arguments is there? 2 arguments. And what are the types of these 2 arguments? Both are integer, right? So 2 arguments plus both are integer. Now compiler will search for the method definition with 2 parameters of integer type. That means this one. So after executing this line, method binding will happen and this method will get called. This is method binding. And method binding is happening. Method binding is happening during compile time. That's why we are calling it as compile time polymorphism. I hope you understood compile time and polymorphism also. Polymorphism, one method name with different forms. See, 1, 2, 3, 4. but it is happening during compile time. What is happening during compile time? Method binding. That's why we are calling it as compile time polymorphism. So let's run and verify it. See, 30 is the answer. And since it is showing blue color, see, all methods are gray, but it is blue. That means this method is getting called. And one more here, one usage. See here, no usage. So during compile time only, compiler is knowing, okay, this method to call. That's why we say this early binding also. Okay. Now I will comment this one. I will write one more method call. Let's say this time I will write 1.2 comma 3.4. Now tell me which method will get called. Both are only two parameters. First of all, number of parameters, two parameters, and both are double values pointer. See, automatically this is showing blue and one usage. So during compile time only we are getting, okay, this method will get called. That is method binding, linking method call to method definition. So now I will run the program and see the output. See, 4.6. Just adding two double numbers. So 4.6. Okay. So I hope it is clear. Polymorphism is one method name with multiple forms. Different forms means different implementation, because inside method definition this formula is different. See, different implementation. This is what we are calling different forms. Okay, and it is happening during compile time, so that we are calling compile time polymorphism. Okay, now why is it called compile time polymorphism? So we have seen it's called compile time polymorphism because the compiler determines which overloaded method to invoke during compilation. We have seen with the example. So there is no need to decide at runtime. Okay, everything is happening during compile time, so making the execution slightly faster. So here they have mentioned some point. Compiler selects the method, which method to call. That is method binding. Okay, it is just to linking the method call to the method definition. Which method definition, which method to call, that is method binding. Decision made before execution. So we have not run the program during compile time only. During compile time only method binding is happening. No runtime method lookup. It is not going up to runtime. We are not running. Before running only these things are happening. That's why we call it compile time polymorphism. Okay. Now let's see what are the advantages of using this compile time polymorphism. So without using this concept compile time polymorphism also we can write the code, right? But we are using this concept of compile time polymorphism so that we can achieve these things. What these things? Improves code readability. Okay, code reusability, faster execution, easy to maintain. So in IntelliJ you can see, right, how we can easy to read, right? The four methods I have defined here. So code readability, code reusability, faster execution, these things come automatically if you are following these principles. Okay, compile time polymorphism. Now let's quickly summarize what we have learned so far. So compile time polymorphism is resolved during compilation. During compilation. And it is also known as static polymorphism. Static means it is not going to runtime. It is not dynamic. Everything happening during compile time. That's why static. And in Java, we have seen it is achieved using method overloading. So for method overloading, we were having set of rules, right? Method name should be same. signature should be different. Signature means number of parameter, number of data type, or it can be both. So this set of rules we follow for method overloading. After following this set of rules, we are achieving method overloading, and from method overloading, we are achieving compile time polymorphism. Okay. Compiler selects the correct method. That is what method binding. Method binding. Linking, I will write it in another way. Linking method call. See, if you understand this meaning, what is method call, what is method definition, that then it is very easy. Okay. Linking method call to method definition. This process is called method binding, and this method binding happens during compile time. That's why we call compile time polymorphism. Okay. That's all for this video. I hope you understood the concept of early binding or compile time polymorphism. Thanks for watching, and I will see you in the next video.